Hello and welcome everyone, I'm John from Avalon. In today's tutorial, we will learn how to build a microservice to connect with external systems. ONEWEB microservice provide a web service node to connect with external systems via an API. For today's demonstration, we will use a similar UI that we built in our previous UI tutorials, and we'll try to connect with the external system to get the values of temperature, humidity, and air pollutant PM 2.5 for a specific location. Currently, as you can see in this UI, all those values for temperature, humidity, and air pollutant PM 2.5 are marked as question mark. To get the real-time values for temperature, humidity, and PM 2.5, I would like to connect ONEWEB with an external service known as AirVisual, where you can explore the air quality almost anywhere in the world. Once you sign up with AirVisual, they provide me the free API in their community package with limited calls. I have signed up for my account and I have got my service API key. In the documentation part, you can easily find out the URL and connection type to connect to their services. So I see the REST API URL and the request connection type method, which is GET. Also, they have mentioned that this external service required 3 input parameters, which are the city, state, and country. In the given example, we can also see the output response from this service, which shows the real-time values of the weather forecast, current temperature, air pollutants, etc. To see an output parameter structure from this service, I also test this API service using Postman, which is an excellent API testing tool and allows you to send HTTP requests and see real-time responses. As shown here, I can see the real-time values for temperature, humidity, and PM 2.5 from this external service. Knowing URL, input, and the output API service response from this external service, we can start to build a ONEWEB microservice to connect to this external system. As mentioned in the previous microflow tutorials, we can start here with the Business Object tab to create input and output business objects for this microservice. So click on Add Parameter and create one input business object. Now we can add 3 input parameters, that is city, state, and country, which are required to send to this external service. Same for the output process parameter, create one output business object and define output parameters. It is to be noted here that the output process parameter structure that we create here inside our microservice should match with the API output response that we are getting from an external service. Now if we look into the output JSON response from an external service, the values I required from this service for given input, state, and country are under the weather object and pollution object. So here TS stands for current timestamp date, TP stands for temperature, HU stands for humidity, and AQUIS shows the current value for PM 2.5. So knowing the output process parameter structure, we can create one output business object, which is list type object, and our required output parameters. So we create weather object and contains 3 parameters, which are the date with parameter type as string, temperature with parameter type as decimal, and humidity with the same parameter type as the decimal. Another object, which is pollution, for getting PM 2.5 values with parameter type as an integer. Now you can click on the Save button on the Business Object tab to save all your parameters. Click on the Workflow tab, drag and drop one start node, one end node, and one web service node and connect them to create your required workflow. Double click on the web service node to open node configuration. General tab is optional. You can rename the node if required. Click on the Business Object tab. Now since this service requires both input and output, select the input checkbox for your service input business object. Add another row and mark the checkbox for your output business object. Click on the web service parameter. In node configuration, you can choose the REST option, open REST tab to enter the REST URL provided by an external service. In this URL, we can replace the static text input mentioned for state, country and city with a microservice input business object parameter to give the input directly from this microservice. For example, state equal to Bangkok in this external URL will be replaced with input bio name dot parameter name, which is state, and do the same for country and city. As mentioned by this external service, choose here the HTTP type as GET, select accept header and content type or application/JSON. Now click on the data mapping button to perform visual data mapping. Click on input parameter mapping. Under REST parameter, create 3 REST dummy object parameters with the same name as the city, state and country, and connect them to do input parameter mapping. Now select output parameter mapping and create the REST parameter with the same name as external API output, which is TS, TP, HU and EQUIS for a date, temperature, humidity and PM 2.5 values respectively. Now let's have a look again at the external service API JSON structure. I'm using here a free JSON reader tool to visualize the JSON syntax for AirVisual, which is our external service API output. Now if you would like to retrieve all these output parameters from this service, you can simply create the same parameter structure in the microservice output business object and don't need to use the JSON path to retrieve values. And if you need only some parameters, like in this case from this external service output, then we can use the JSON path. As I can easily check here, the value of the TS parameter, which holds the date, resides inside data object, then the current object, then the weather object, and then finally under TS parameter. So the JSON path to directly access the TS value to retrieve date will be $data.current.weather.ts. Once you already know the JSON path to directly retrieve the TS value from an external API output, you can click on Edit the TS parameter and mention the direct JSON path inside the JSON path field. Similarly, you can mention the JSON paths for TP, HU and EQUIS to retrieve the direct values. Now you can connect parameters like TS with date, TP with temperature, HU with humidity and EQUIS with EQUIS to perform the visual data mapping. Click on Done button to close the mapping window. Also click on the Done button to close the Web Service Parameter tab. Now you can click on the Save button to save all your configuration. Move to the Simulation tab. In the Simulation tab, you can manually enter your desired city, state and country to check the output from this external service. Click on the Start button to test this microservice. As you can see in the Output tab, I can get the expected real-time values for all my parameters from an external service. Next is to integrate this microservice with our design UI. Click on the App switcher to open your UI screen. Once you have the UI screen open, click on the page content on bottom page hierarchy. Add one action using this plus button. Write the event name as load. Choose Microflow tab. Select your project name, which is your application name. Select your microservice process name, which is getWeatherUpdate. Now here we click on Map Process Parameter to define page state. Create 3 page states, which are the city, state and country. Since I would like to retrieve results on UI for the city as Payathai, I can use these values in the page state default field. Similarly, I use the default value for the state as Bangkok and the country as Thailand. Now you can connect the page designer parameters with the microservice input parameters to perform visual data mapping. Click on the Save icon and close this window. Also click on the Save button in this action configuration to save this action. Now select the UI element which is container here and use the Connect to Data icon to open the Connect to Data window. Choose the Microflow tab and connect it with the output of your microservice. Now on the first question mark text UI element, I would like to get the real-time value for temperature. Select the question mark text UI element, click on Connect to Data icon, choose the Microflow tab, enable data from parent option, and choose temperature from the output parameter list. Save and close this window. Similarly, you can connect the other two UI elements with humidity and PM 2.5 parameter respectively. Now your Microflow integration with the UI screen is completed. You can now save your application. Click on the Play Me button to get the URL. Open this URL to test your application. As you can see in the application runtime results, you can get the real-time values for temperature, humidity and PM 2.5 from an external service on your ONEWEB design UIs. So this tutorial has demonstrated how you can use ONEWEB microservices to connect with external systems. Please like and subscribe to our channel for more information on ONEWEB features. Thank you for watching this tutorial.